Hello, this is Dr. Mode, and in ICP class today we're going to continue our chapter on sound, and section 2 is called Properties of Sound. Our scripture from today comes from Psalm chapter 92 verses 1 through 4. It is good to give thanks to the Lord and to sing praises to your name, O Most High, to declare your loving kindness in the morning and your faithfulness every night, on an instrument of 10 strings, on the lute and on the harp, with harmonious sound. For you, Lord, have made me glad through your work. I will triumph in the works of your hands. The big idea in chapter 10 is sound waves are longitudinal waves produced by vibrations. As you can see, we finished section 1, and today we are doing section 2. The essential questions for this section are: how are amplitude, intensity, and loudness related? How is sound intensity measured? What is the relationship between frequency and pitch? What is the Doppler effect? Intensity is the amount of energy that passes through a certain area in a specific amount of time. When you turn down the volume on your computer, you reduce the energy carried by the sound waves, so you also reduce their intensity. Some sounds are so loud that they can be painful to hear. Loudness is the human perception of sound volume and primarily depends on sound intensity. When sound waves of high intensity reach your ear, they cause your eardrum to move back and forth a greater distance than when sound waves of low intensity reach your ear. So if you look at this picture, you can see that it's a decibel scale. Decibel is the measure here of loudness. And if you look at it, on the left side, it starts with 0 decibels, and that would be silence. Rustling leaves is listed as 20 decibels. Purring cat, 25. An air conditioner, 50. A cafeteria, 80 decibels. A rock concert would be 110. The threshold of pain is listed as about 120 decibels, and a jet plane taking off is 150 decibels. Pitch is how high or low a sound seems to be. The notes on the right side of a piano have high pitches. The pitch of a sound is primarily related to the frequency of the sound. So here we have some notes that are listed, some common notes starting with the middle C and going up. And what you can see in the bottom of this picture is the number of hertz associated with the frequency of those sounds. Imagine that you are standing at the side of a racetrack with race cars zooming past. When the cars are moving toward you, the pitches of their engines are higher. When the cars are moving away from you, the pitches are lower. This is called the Doppler effect. The Doppler effect is the change in wave frequency due to a wave source moving relative to an observer, or an observer moving relative to a wave source.